Hello students. We know that integration is reverse process of differentiation. Like if we differentiate function fx with respect to x, suppose we get function gx, okay, and if we integrate function gx, we get function fx back. We have d of fx is equal to gx multiplied by dx, okay. Now we integrate both sides. On LHS we get fx, okay. On RHS we have integration of function gx with respect to variable x. Derivative of fx is gx, then integration of gx is fx. Means integration is reverse process of differentiation. We know this, okay. In this video we will see definite integration as a area function. Now look at this figure on the top. We have graph of function y is equal to fx on the coordinate plane, okay. We have this area, this bounded area. Here function y is equal to fx is continuous and differentiable. ये ध्यान रखना है कि फंक्शन fx जो है वो continuous and differentiable है यहाँ पे. We have this bounded area bounded by 4 curves. Y is equal to fx, x-axis, y-axis, and this variable line, okay. This is vertical line. Here x is variable, okay. These two lines are fixed. This curve is fixed, but this line is variable. This vertical line is variable. This is called area under curve y is equal to fx. When we say area under curve, lower curve is x-axis, okay. Now this is variable area because this line is variable. यहाँ पे दो partitions है, y-axis and this line. This is fixed line, but this line is variable. We can slide this line, slide this partition. आगे पीछे कर सकते हैं, तो ये एरिया जो है वो क्या होगा, वेरिएबल होगा, फिक्स नहीं होगा. This area depends on value of x, okay. Suppose this area is ax. This area is function of variable x, okay. Now what I do, I draw one line here, one vertical line at distance h from this line, okay. So abscissa of this point is x plus h. Coordinates are x plus h comma 0, okay. This width is h. You want to keep h as small as possible. Now we shade this area, this region, in fact, okay. Suppose this is point D, this is point E, okay. Then what is area OADE? Area क्या होगा in notation? Area of region ABCO is A of x, okay. Then area of region ADEO will be A of x plus h, okay. Then what is this area? Area of region BDEC. Area of region BDEC is A of x plus h minus A of x. From the area of region ADEO, we subtract area of region ABCO. ठीक है ना? Okay. Now what do you do? We draw this rectangle. From point B, we draw a line perpendicular to this line, okay. So we have here a rectangle BD1 EC. Now what is area of this rectangle? This width is h, okay, and this height is f of x. ठीक है, function का value क्या होगा x के लिए? f of x होगा ना, okay. Now this area is certainly more than area of this rectangle, and area of this rectangle is h multiplied by f of x. So we have this area greater than or equal to h multiplied by f of x, okay. Now we draw one more rectangle. We draw this rectangle, okay. Now height of this rectangle is f of x plus h. Abscissa of point D is x plus h. So value of function is f of x plus h. So this height is f of x plus h and this width is h. So area of this bigger rectangle is h multiplied by f of x plus h. Now certainly this area is less than or equal to area of this rectangle. Okay, so we have this area less than or equal to h multiplied by f of x plus h. Together. Okay. Next, what we do? We divide all sides by h. Here h is positive, so we have f of x less than or equal to a of x plus h minus a of x upon h. This is less than or equal to f of x plus h. ठीक है ना? h पॉजिटिव है तो इनइक्वालिटी में कोई चेंज नहीं आएगा, इनइक्वालिटीज वही रहेंगी. ठीक है ना? Sign of inequality does not change. Okay. Now what we do? We apply limit h tends to 0. Okay. So we have limit h tends to 0 of f of x less than or equal to limit h tends to 0 of a of x plus h minus a of x upon h. This is less than or equal to limit h tends to 0 of f of x plus h. Okay. Now this is f of x. Okay. Also this is f of x. Okay. So from sandwich rule, sandwich theorem of limit, this limit is f of x. And what is this limit? From the first principle of differentiation, this is derivative of function a of x. ठीक है ना? Area function. So what we are getting? We are getting a prime of x is equal to fx. ठीक है ना? Derivative of area function is function fx. Okay. Now what we do? We integrate both sides. We get a of x is equal to integration of function fx. ठीक है ना? So here integration of function fx is area function. Okay, but this area is for x belongs to 0 to x. This is area under curve for x belongs to 0 to x. So what we do? We put here limits 0 to x. 0 is lower limit and x is upper limit. So area under curve for function y is equal to fx is this integral. Integration of function f of x with limits 0 to x. This is called definite integration of function fx, and this is nothing but area function, okay, which depends on the value of x. Okay. Now consider two vertical lines with respect to coordinate axis. X is equal to a and x is equal to b. Then what will be this area? Area under curve y is equal to fx between the limits x is equal to a and x is equal to b. इस एरिया को इंटीग्रेशन के फॉर्म में कैसे लिखेंगे? दिस एरिया इज एरिया ऑफ रीजन डेल्टा ऑफ ए बी वन सी वन ओ. डेल्टा मीन्स एरिया ऑफ दिस रीजन ए बी वन सी वन ओ माइनस एरिया ऑफ रीजन ए बी सी ओ. ओके, दिस एरिया इज ए ऑफ बी. ओके, and this area is a of a. Okay, a of b is from this formula integration of function fx for limits 0 to b minus this area. So we have here integration of f of x between the limits 0 and a. Okay, now this area is between limits x is equal to a and x is equal to b. So we can write like this: integration of f of x between the limits a and b. So we have integration of function fx between limits a and b is a of b minus a of a. ठीक है ना? This is fundamental theorem of definite integration. Here derivative of function a is function f of x. Generally we write here f of x. Okay, we write f prime of x is equal to fx. Okay, so we have this value is equal to f of b minus f of a. ठीक है, समझ में आ गया? So here we found the relation between area under curve and definite integration.